This is the first demonstration titled Beads or BBs. Please make sure you've written down both titles, as we will refer to this lab as either one of those titles, Beads or BBs, on a future test or exam. This lab is actually more of a simulation of the molecules in 3 different states of matter: solid, liquid, and gas. We are going to use small, tiny white beads to represent or simulate molecules in those 3 states of matter, and we are going to apply energy using a back massager to add energy, molecular kinetic energy, to the molecules. So the first state of matter we're going to take a look at is a solid. As you know, solid molecules are tightly packed. They have a set or definite shape and volume, and they tend to vibrate in place. So observe the beads and write down your observations.
Applying energy.
Okay, hopefully you're able to see a small amount of energy in those molecules and that they vibrate in place in a solid. The next state of matter we're going to demonstrate are the molecules in a liquid. This time we're going to add a little bit more energy, and hopefully you will notice that the molecules are going to slide past each other.
Applying energy.
Okay, the last demonstration for this one are the molecules in a gas. Obviously, they have the most kinetic energy of these 3 states of matter, and so you will hopefully see some very exciting molecules here.
Applying energy. Oops. Alright, this demo is called Potassium Permanganate, or KMNO4. Write down both titles. You might see it referred to by both later. What we have here are 3 beakers with 3 different temperatures of water. One has hot water that's just a little bit below boiling. One has room temperature water that's around 68 degrees. And one has cold water that's about 36 degrees Fahrenheit. What I have here are potassium permanganate crystals, and we use these crystals because of the color. It actually has a nice bright color, purple color, that we can see very nicely in this demonstration. What I'm going to do is put the same amount of crystals in each of the 3 beakers, and what we want to try to observe is the differences between in terms of how the dye or the particles spread throughout the water. Before I start, though, you might want to think about what the molecules are doing in each of the beakers right now. What are the molecules doing in the cold water right now? How are they packed? Are they moving very slow or very fast? What are they like in the room temperature water? What about the hot water? Are they moving very slow? Are they moving violently? So think about how those molecules are behaving in all 3. I'm going to start with the cold water, and I'm going to try to put about the same amount of potassium permanganate in each one. Okay, for the cold water, notice that the color is spreading pretty slow, very slowly. If you look at the beakers actually from the side, you'll notice that there are areas where color has not reached. There are areas of where there's still clear water. If we look at it from the top, you'll notice that there is a big clump of crystals still in the bottom of the beaker that have not fully spread out yet. Moving on to the room temperature water, I'm going to put about the same amount in. Notice that the color is spreading just a little bit faster. if we look at this one from the side, you may notice that more of the color is spread around in the body of the water, much more so, or maybe just a little bit more so, than in the cold water. And then finally, the hot beaker. Again, I'll put about the same amount of potassium permanganate in. Notice how the color spreads very quickly in the hot beaker. If you look at this one from the side, you'll notice that the color has spread throughout the whole beaker, and it's almost fully colored. There is a term that we use to describe what's happening here, and that term is diffusion. Based on this demonstration, how does temperature affect diffusion, or the rate of diffusion? All right. This demo is called Angel Chimes or Angel Carousel. Notice that at the bottom there are about 8 candles. Up top there is a propeller, and the blades are shaped sort of like fan blades. Here there are 3 angels that are all facing the same direction, and those are positioned on an axle that's in a vertical position. Alright, what I'm going to do is I'm going to light the candles at the bottom, and we're going to see what effect that has on the angels up top. Okay, what you notice is that when the candles are lit, the propeller starts to spin. Can you explain why this is happening? There is a word that is a vocab word that is used to describe what's going on here. What is happening to the air that's next to the candles, that's right above the candles? Is that air gaining energy? If it's gaining energy, then how is that affecting the molecules? They're probably moving faster, hitting harder, spreading apart, becoming less dense. If those molecules of air are becoming less dense, is it likely that they're rising and hitting the blades of the propeller? What happens to that air when it's away from the propeller? Well, it probably does the opposite. It probably loses energy, the air contracts, and then it probably sinks. More air is heated, and it continues in that cycle. This cyclic or uneven heating is called convection.